Alright guys, this video starts 4.3. It has a lot of information in 4.3, so it might take up 2 videos, so be prepared for that if it ends up happening, but we'll just take our time through it and see what happens. So 4.3 is kind of extending trigonometry and bringing about what's the unit circle and what all that entails. So before we get started on that, remember one of the big things about this is how to draw an angle. So whenever we draw an angle like so, we call this side the initial side because it's where it starts, and then we call this side the terminal because that is where it ends. And we draw an arrow to show our initial to our terminal, and you can let alpha, theta, whatever represent your angle. Remember, and we kind of did this a little bit in Math 3, positive angles, so positive 30, positive 400, whatever, we always go in the counterclockwise direction. And negative angles always go in the clockwise direction. So remember, this this initial side is always that positive x-axis, and then you kind of go up, which is counterclockwise for positive, and you go down for negative. And that's whenever it's in what we call standard position. So that would look something. You have your x and your y-axis. X and y. I'm going to graph an angle, positive, in standard position. I would start here, and then it would go something like that, would be my alpha, theta, whatever. Here is my initial side of a negative angle, and it would go this way, could be a negative. So this is a positive angle, and this is a negative angle. Okay, the first thing you need to be mindful of is making sure you can draw the angles, because then when we apply all the trig stuff to it, it gets a little bit more complicated, especially if you can't draw the angles where they're supposed to go. So then the next thing we're going to talk about is coterminal angles. And if you take a little English lesson, the prefix co means with, and then the terminal. So these are going to be angles with the same terminal side. So angles with same terminal side, but of course they're going to have different measurement. An example could be a 30-degree angle, right? Let's see. Cool. So 30 degrees, something like this, right? And something that is coterminal with that would have the same here, terminal side, but it might go all the way around and get there, or it could go the negative direction and get there. So if you remember coterminal, there are 2 ways we can kind of figure it. We add or subtract 360, which is the full circle, or if we're in radians, we do plus or minus 2 pi, because we want to keep it in radians. If our problem's in radians, it needs to stay in radians. Okay, we're going to do a couple examples of this, and then go from there. So, if I wanted to find the coterminal of 30, we traditionally give a positive and a negative coterminal. So the positive, I would just add 360, and that would give me 390. If I subtract 360, it gives me negative 330. And there are your 2 coterminals, a positive and a negative. Now, you could add and subtract 360 multiple times, and those would be more positive and more negatives. Since it's a circle, it can go around as many times as you want. If you start off with, say, a negative number, say, for example, negative 400, when I add 360, I still have negative 40. So even though I added, that's still a negative coterminal. I would have to add 360 again to get the positive coterminal of 320. So this is a negative and that's a positive, even though I've added 360 twice. And subtracting, whenever it says a positive coterminal, the number has to be positive. When it says a negative coterminal, the number has to be negative. Excuse me. No matter how many times you have to add or subtract the 360. And then just for us to have an example of it in radians, 2 pi over 3. When I add 2 pi, it's, always easiest to have common denominators when adding fractions. So in this case, 2 pi with a denominator of 3 would be 6 pi. So that would give me 8 pi over 3. And if I were to subtract 6 pi over 3, it would be negative 4 pi over 3. So here's your positive and your negative coterminal whenever they are in radians. To be able to graph these, the easiest way to do that would be to convert the 2 pi over 3 to degrees. And a lot of us see that a little bit more visually than the 2 pi over 3. If you think about it, 2 pi over 3 is almost a full pi. So this would be in quadrant 2. Then next, kind of relating things to 4.2 and the fact of what if I said let theta be an acute angle in standard position whose terminal side contains the following ordered pair. And what I want you to do is find the 6 trig functions of that theta. So let's do number 4. We're going to let the ordered pair be 5, 3. So if you think about it, this is in quadrant 1 because it's a positive ordered pair. So if I plotted it, it would look something like this, right? And this could be my theta. Where this ordered pair is 5, 3, my x is here and my y is 3. Then my hypotenuse, or we let that, it's kind of like r, because like the radius of our circle, because remember we're going to relate this back to the unit circle later. We can find it by using the Pythagorean theorem. So let that be r. R squared is 3 squared plus 5 squared, 9 plus 25. R squared then is 34. So r is the square root of 34. Then, hopefully, you should be able to find all your 6 trig functions pretty easily. So the sine of theta would be 3 over the square root of 34. Remember, we must rationalize that to 3 square roots of 34 over 34. 34 does not reduce as a radical, so we don't have to worry about that. Cosine of theta ends up being 5 square roots of 34 over 34. Tangent of theta is 5 over 3. And then we do our reciprocal function. So cosecant of theta would be square root of 34 over 3. Secant of theta would be square root of 34 over 5. And cotangent of theta would be 3 out of 5. So pretty short and sweet. What becomes really fun is, what if we're not in quadrant 1? Some people get a little confused because they think the angle is no longer acute. So number 5, let's do like -2 and 7. This would be in quadrant 2. And it would kind of be like way up here, right? And that would be our angle if we drew it. But remember, when we're talking about these little right triangles, we always draw them back to the x-axis. So the theta that we're referring to is right here. It's our reference angle of our triangle. This is still -2, and this is still 7 because it represents our x and our y. Our r, we would still find by the Pythagorean theorem. And in this case, r squared would be 49 plus 4, or what is that, 53? So r is the square root of 53. And then you can write all your cute little trig functions from there. The main thing to remember with this is because the x is negative, then all of those trig functions that need that adjacent side will have that negative number. Okay? So then let's generalize this real quick. We call these definitions our trig definitions, whereas before we had the geometry definitions, these would be our trig definitions. And that is usually kind of like our x or y's and our r's. So for trig, sine of theta is y over r, because it is like the y coordinate over the radius. Our cosine would be x over r, adjacent. And then tangent is going to be y over x. And our reciprocal functions are going to be just what they are. We're going to flip those fractions. So cosecant is r over y, secant is r over x, and cotangent is x over y. So these are very helpful whenever it comes to ordered pairs. If you don't necessarily want to draw triangles, you can kind of remember this. But it is very, very important for you to learn these. And remember, the easiest way to find r is by using that Pythagorean theorem, which would just be x squared plus y squared, and then taking the square root. Also remember with these, r is always going to be a positive number because you are squaring two numbers and then adding them up, so r is always positive, which then makes it important. It will never be 0, so it's okay in those fractions. But these two guys, we have to be careful. Here x cannot be 0, and here y cannot be 0. Otherwise, those will be undefined. So there will be a couple of times when tangent and cotangent are undefined, and we'll talk about those in a few minutes. The last thing in this video is going to kind of relate this back to our special right triangles. If you remember in the 4-2 video, told you it's very important for you to go ahead and memorize our reference triangles that we use for 45, 45, 90 and 30, 60, 90, because those are going to be the type of triangles that we're going to see all the time in this section. We're going to be asked to graph an angle and find a certain trig function related to that angle, and it will end up having a 45, a 30, or a 60 reference angle. So for example, with that, let's just do, I don't know, something fun, secant of 315 degrees. Now, just because I ask you for secant doesn't mean you shouldn't know all the other ones, but we'll just keep it simple for now. 315 degrees, it starts here in quadrant on the positive axis. Then we go up in quadrant 1 and come around all the way here is 315 degrees, right? What that means then, when I draw my reference triangle, is that this angle right here has to be 45 degrees because I have to get back around to 360. Then, based off my rules, this is 1, 1, and the square root of 2. But because this is in quadrant 4, this one's actually negative. Secant is r over x, and so that would be square root of 2 over 1, or the square root of 2. In the next video, we're going to do some more practice of this, and then continue on with quadrant angles and things of that nature. But this kind of sets us up for the unit circle stuff.